Okay, so now today what we'll discuss is we'll calculate the electric field due to the dipole on the points of an equatorial plane. Okay, in the last class we have calculated, in this class we have calculated about the electric field or electric field at a point on the axis of the dipole. So this is a dipole. On the axis of the dipole we have calculated, on the axis of the dipole we have calculated the electric field. So in this video, in this discussion, what we will do, we will calculate the electric field on the equatorial point. Okay, so what we will do, so we will calculate the field, the electric field of an dipole for the points on the equatorial plane. Okay, so as in the last video, also in the last discussion, I have told you that what is a dipole. A dipole is a two equal and opposite charges, let's say plus q and minus q, are separated by a very small distance, let's say 2a. Okay, 2a and makes one dipole. Okay, so in this dipole, let's say this is the center of the dipole, so this will be a and this will be the distance from center to this position will be also a. Okay, now, and what will be the direction of the dipole? In the last discussion I have told you also that the direction of the dipole is from, by convention, negative to positive, so this will be the direction p cap. Okay, so in the last video we have calculated the electric field due to this dipole on a point on the axis. Okay, so now we will calculate the electric field of a dipole on the equatorial plane. So how will you draw the equatorial plane? Let us draw another diagram. So let's say this is your plus q charge, this is your minus q charge, separated by a distance 2a. This is the point of your this is the bisector of this line. Okay, and this point is the center. So now you can draw the plane which is passing through this center. You can say this is the plane, you can say this is the equatorial plane, or this is the equatorial plane, or this plane bisects the line joining the plus q and minus q. So what we'll do is we'll calculate at a point p, we'll calculate the electric field at a point p on the equator. So as I have told you that in a dipole there are two charges, plus q and minus q charges there. So what will be the electric field at a point p? The electric field at a point p due to plus q charge will be outward, because as you know the direction of electric field at a point p will be outward direction. So this will be E plus q. And what will be the electric field due to this charge minus q? So electric field due to this charge minus q, electric field due to this charge minus q will be in this direction, that I will write E minus q. So these are the two vectors. So resultant of this E plus q and E minus q at the point P will give you the electric field or total net electric field at point P. This side. So we have to calculate first E plus q, E minus q, then we have to add it vectorically and we have to find out what is the net electric field at this point P. This is what we have to do in this one, in this calculation. So as you know, what is E plus q? let us do it quickly. So what is E plus Q? E plus Q, as you know, that is 1 by 4 pi epsilon naught magnitude I am writing. So Q by R, not R. What will be the distance from here to here? Can you say? Because this is the point of midpoint, or you can say this is the bisector. Okay, so this is the bisector, so this will be the center. So here the distance will be A, and distance from here to here will be A. Okay, it's a midpoint. That's why, and the point P from the base is, let's say, at a distance R. So what will be this one? From Pythagoras theorem, you know that this will be A square plus R square root over. So the distance between plus Q and P is R square plus A square root over. So this will be R square plus A square root over whole square. Okay, so this is the magnitude of E plus Q. Okay, electric field at point P due to plus Q charge. What is E minus Q? E minus Q, you can write, is 1 by 4 pi epsilon naught. Magnitude I am writing, so I'll write Q, and the distance from this point P to this point is same, because this is R, this is A, so it will also be R square plus A square root over whole square. Now you can see that the magnitude of both plus Q and minus Q, the magnitude of both electric field due to plus Q and electric field due to minus Q are same. Okay, so what will be the magnitude? You can see one thing, this electric field on y direction, okay, on y direction it will have E plus Q sin theta. Okay, so this will be theta and this will be theta. Why? Because the angle between, let's say, with the angle between this base and this line is, let's say, theta, and this is theta, because the two this is an isosceles triangle, so theta and theta. So theta and theta, this total angle will be 2 theta. Okay, so if it is 2 theta, then as two vectors are equal in magnitude, so the resultant will bisect this angle, so it will become theta and theta. As it will become theta and theta, now we can say this angle and this angle are alternate interior. So as two alternate interior angle are equal, so E must be parallel to the base. Okay, and E is in the right hand towards right, but what is the direction of the dipole? As I have told you, by convention the direction of the dipole is from negative to positive charge, so that direction is P cap is from negative to minus Q to plus Q charge. Okay, and E is in the right side, so the direction and P and E will be opposite to each other. Okay, so now what is our target? So our aim is to calculate the electric field. Okay, so I was saying that this is theta, so the component of E plus Q on this one, on this parallel line, it will have E plus Q cos theta, and E minus Q also will have the component E minus Q cos theta. Now E minus Q will also have a vertical component, that is E minus Q sin theta, and E plus Q will have also a vertical component, that is E plus Q sin theta. But as E plus Q and E minus Q magnitude are same, so E plus Q sin theta and E minus Q sin theta both will cancel each other, because they are acting on the same point and opposite in direction. So E plus Q sin theta and E minus Q sin theta, they will cancel each other, because they are opposite in each other. The direction is opposite to each other. Okay, so what will remain? Only this component E plus Q cos theta and E minus Q cos theta will be taken into consideration. So the net electric field E will be E plus Q cos theta. Let's write down the magnitude. E plus Q cos theta plus E minus Q cos theta. And what will be the direction? The direction is opposite to P, right? So this will be minus P cap. Okay, so now you can write this as both are equal, so you can write 2 times. Okay, so this will become 2 times of E plus Q. What is the value of E plus Q? Let us write down. Let us write it. So 1 by 4 pi epsilon naught okay, 1 by 4 pi epsilon naught. This is q by r square plus a square. Root over whole square means root over will be removed, so this is r square plus a square. Right, now cos theta is there common, okay, so 2 times of this one into cos theta. So cos theta is, let's write it cos theta, and minus is there, minus p cap, so let's write p cap. Okay, minus I have taken in the I write it in the left side. So now what you can write, you can now simplify it. So this will become minus, okay, so now in this step what we will do, we will remove cos theta. So what will be cos theta? As you know, from here you can clearly see that cos theta is equal to, this is theta, so b by h, okay, or b by h. What is b? Base is here your a, and h is a square r square. So a by, what is cos theta? A square plus r square. Root over means I can write half, okay. So this will be minus 2q by 4 pi epsilon naught, okay, 1 by r square plus a square, and cos theta is a by r square plus a square to the power half. Clear? Now I'll multiply. Okay, so nothing is there means the power is 1. So power is same thing, r square plus a square power 1, r square plus a square power half. So power will be added as the base is same. So what we will do, just we will write down minus 2q, okay, minus 2q a by, and p cap is there, 4 pi epsilon naught, okay, that is 1 by r square plus a square, 3 by 2, 1 plus half is what? 3 by 2 p cap. Clear? Now in the same procedure we will follow what we have done for the axial case, okay, or for the points on the axis of the dipole. Okay, so here also we will consider, as you know, r is greater than a, so square of a will be very small than square of r square, so we will neglect a square. So if we will neglect a square, then what you will get? So you will get that your total electric field E will be equal to minus 2qa, okay, a square you will neglect, so this will be 4 pi epsilon naught 1 by r square to the power 3 by 2 p cap. R square to the power 3 by 2 means 2 will cancel, okay, square means power to the power will be multiplied, r into means square 2 into 3 by 2, so 2 will cancel, 3 by 2 will remain. So you can write E will be equal to minus 2qa by 4 pi epsilon naught, that is 1 by rq p cap. Now from the definition of your dipole moment, what is the dipole moment definition? That is p vector is equal to either charge, one charge into the distance between two means the charges in a dipole, okay, that is 2a in p cap. This is the definition of, this is dipole moment, this is dipole moment vector, okay, this is dipole moment. So now in terms of dipole moment vector, what you will write, your 2 or q into 2a p cap will be p vector, okay. So I can write the electric field vector E. So if in the exam, as I told in the last video also, if it is not mentioned that write the electric field in terms of dipole moment, no need to write, only you can skip, you can you can write up to this much, okay. If the question is there, then write or express the result or electric field in terms of dipole moment vector, then you should use the dipole moment vector p here. So q into 2a p cap will be the dipole moment vector p, so it will be minus 1 by 4 pi epsilon naught. This numerator will become p vector, in the denominator rq. So this is your electric field electric field on a point on the equatorial plane of a dipole, on the equatorial plane of a dipole. Okay, so this is what the field of an dipole for the points on the equatorial plane. So for a point on the equatorial, so you can take any point on the equatorial plane at a distance different distance different at a different r, so your expression will be same. You can find out the electric field at a point on the equatorial point. So but you can see the same thing, like the electric field due to a dipole varies as rq, 1 upon rq. That means the electric field decreases faster than the electric field due to a single charge, because for a single charge you know that the electric field decreases with r square or distance square in the denominator, 1 upon r square. It varies as 1 upon r square. But due to a dipole, due to system of two charges, the electric field varies as 1 upon rq. That means it varies faster or it decreases faster than due to a single charge. And in the denominator rq is also here for the equatorial case, and in case of your your axial case also, the electric field also varies in terms of rq. Okay, so what is the difference between axial and equatorial? You can say this is axial, this result we got axial, and this is the result we got equatorial. So you can check the differentiate between the two. You can see only if we multiply, okay, if we multiply a -2 in equatorial, you will get the axial result. Okay, so in other terms you can say -2 times of E equatorial is equal to E axial. You can just draw a relationship between them. Okay, so if we'll multiply -2 with the equatorial case, then you will get the axial result. Okay, so this is just a relation between them, nothing else. So this is the result of an equatorial electric field due to the equatorial electric field for a point on the equatorial plane due to the dipole. Okay, so thank you. In other video I will discuss some other topic. Thank you.